what we're looking at today is the graphs of rational functions. So first off, what a rational function is it is just two polynomial functions being divided. So for example, your rational function is just f of x divided by g of x. And the only other thing that you have to take note of is that g of x is not equal to 0. That's because you cannot have a 0 in the bottom of a fraction. So before we get started today, let me just warn you, today is going to seem like a lot. We are going to do several days of this. The key is to just break it down one step at a time. So when we look at these two examples, the question asks us to graph the following functions as transformations of the reciprocal function. So let's pause. What is a reciprocal function? So you recall the reciprocal function is just 1 over x. So if we think back to a couple weeks ago, this is equivalent to x to the negative 1. So you have an odd exponent that is negative. So that tells you that your original equation is going to be graphed in the first and third quadrants. Okay, and we're going to look at, how are things transformed from that. So if we look at example 1, the key is that we need to break it up. So first off, we can rewrite this and kind of take it apart and make negative 2 out in front and then put 1 over x plus 5. And the reason that works is because if we put it back together, we would be multiplying that negative 2 into your numerator. So as we look at this, we can now tell that this has been shifted left 5 units. It's been vertically stretched by a factor of 2. And then you also have this negative out in front telling us that it has been reflected. So all of those pieces are the transformations we've already been talking about. So with your asymptotes are originally at your x-axes. In other words, if I look, my original asymptotes are the x-axis and the y-axis, but now it's been shifted. So I'm going to do this in red. It's been shifted left 5 units, so over 1, 2, 3, 4, 5 units here. It hasn't been shifted up and down, so you still have the asymptote there. Okay? Now, originally, your graph is in the first and third quadrant, but because it's been reflected, it's now going to be in the second and fourth. Okay? Now, keep in mind, when I say quadrants, I'm referencing my new asymptotes as kind of that dividing piece. I'm not worried too much about the vertically stretched piece. Okay? So don't worry too much about that piece in terms of being specific when you graph. The next part of the question says to identify your horizontal and vertical asymptotes. So your horizontal asymptote is still going to be y equals 0. It hasn't been shifted up and down any. Your vertical asymptote is going to be x equals negative 5 because it's been shifted left 5 units. It then goes on to ask us for the domain and range. So your domain is everything but negative 5. So when we write that in interval notation, it looks like this. Don't forget parentheses, not brackets. Your range is everything but 0. So negative infinity to 0. And then it picks back up 0 to infinity. Again, parentheses, not brackets. So then as you look at this, it also asks us to state the limits. So your limits, you have f of x as x approaches infinity. So as we look further and further to the right, our graph approaches 0. And then as we look further and further to the left, our graph also approaches 0. So as it approaches negative infinity, it's also going to be 0. Now the other thing to be mindful of is you actually have 2 other limits to consider. So this part is new. You've got the limit of the function as x approaches negative 5. And here's the key. If your graph is approaching it from the left, you're going to actually use a little negative up here. It's kind of where the exponent would be. But it's telling you that you're approaching the graph or the asymptote from the left-hand side. And as if you're approaching it from the left-hand side, your graph is growing exponentially. So it's going to approach infinity. Now you also have a situation where it's approaching it from the right-hand side. So your limit, and I'm going to have to write small here, as x approaches negative 5, from the right side, you're going to use a plus, indicating it's coming from the positive side. It's approaching negative infinity because it's going down from that side. Okay, so those 2 pieces are new. Now, when you look at example 2, you're going to be doing the same thing, but to start, our starting point is a little bit different because we cannot just pull it apart like we did for example 1. For example 2, your starting point is that you need to go ahead and divide using long division. So set this up. So what times x gives you 3x? That's going to be the 3. And then from there, you're going to multiply around. So you have 3x minus 3. And then when you subtract, remember you are doing -2 minus a -3, which turns into a 1. So when we rewrite this function using that division, you're going to have the 3 plus our remainder of 1 over x minus 1. Now keep in mind, if it makes sense to you, go ahead and put that 3 on the backhand side to help you see your transformations. But this tells us it's gone up 3 units, and this tells us that it has gone right 1 unit. We don't have any sort of stretching or reflecting going on. So now when we go ahead and graph this, our new asymptotes, we're up 3. So our new asymptotes are going to be here and here. And so then when we go ahead and write those, our vertical asymptote is at x equals 1. Our horizontal asymptote is at y equals 3. Okay? Moving on to domain and range. Your domain is everything but your x equals 1. So it's going to be -infinity to 1, and then picks back up 1 to +infinity. Your range is everything but 3. So again, in interval notation, it will look like this. And then you have to go ahead and include your limits. So again, when we look at our graph, we have to figure out where this graph is going to be. It originally is in the first and third quadrant. That's your parent function. It has not changed because it hasn't been reflected. So it's still going to be here and here. So your limit of f of x as x approaches -infinity is going to be that asymptote of 3. So it's also going to be the same if you go to the right. So +infinity. So both of these are going to be 3. Your new limits, or the stuff that we just covered new over on the left-hand side, is we also have the additional limits of your x as it approaches 1 from the left-hand side. So as it approaches from the left-hand side, it's getting smaller. And then your limit as x approaches 1 from the right-hand side is getting bigger. So it's approaching +infinity. All right, so again, there's a lot of little pieces to pick apart here. Now, this next piece that I'm going to show you guys, I need you to just kind of process this. I'm going to actually throw in a little bit of a shade here so that way you guys can kind of pick this apart bit by bit. Okay, so if you guys look at this, we're going to talk about your graphs and the characteristics. So as you look, the key to figuring out your horizontal asymptotes is comparing your degrees. Okay, so when your degree of the top is less than the degree of the bottom, your horizontal asymptote is just going to be y equals 0. Then you have a situation where if the degree of the top is equal, you're going to be looking at your leading coefficients. So your horizontal asymptote is going to be the leading coefficient of the top divided by the leading coefficient of the bottom. So this might be a whole number, it might be a fraction, it just depends on what those leading coefficients are. The last option is if your degree of the top is greater than the degree of the bottom, you actually will not have a horizontal asymptote, but you will have an asymptote that you have to work to find. Okay, so there is no horizontal asymptote, but you're going to divide in the quotient without the remainder. Okay, we're going to look at this. So just the top part of that long division without the remainder is going to be your asymptote. Okay, now one of the things I want to encourage you guys is I would encourage you either to highlight this in your notes or make a separate note card or make maybe a couple sticky notes, something to keep this handy, because we're going to be looking at this and using this for the next couple of days, and it's easier than having to flip back and forth if you have kind of a separate cheat sheet. Now the other thing, we have horizontal asymptotes are determined by degrees. Your vertical asymptotes, where you are looking for that is you are looking at the denominator. So those occur at the zeros of the denominator. And the key is as long as they are also not zeros of the numerator. And we're going to talk about what happens if you have the same zeros in the bottom and in the top. Okay, so vertical asymptotes, you look at the denominator and find the zeros. X-intercepts, those occur when your zeros are in your numerator. So you look at your numerator, find the zeros there. And then the last one, your y-intercepts, all you're doing for that is plugging in 0 for x and evaluating your function. So the value of f of 0 if it's defined. Now here's the key. Notice for both vertical asymptotes and x-intercepts, there's that little piece in there that says as long as they don't match with the other. So for example, for your vertical asymptotes, it's the zeros of the denominator as long as they're not also zeros of the numerator, and vice versa for x-intercepts. So what happens is if they share a zero, you're going to have in your graph what's called a hole. All right, and in your hole, or the way that you would find that hole is you would have zeros that occur both in the numerator and the denominator. So you're going to have it in both places. All right, and we're going to do plenty of examples of this, so please, please, please do not get overwhelmed. All right, so let's take a look at what this would look like. On the back, and we're going to refer back to that slide a couple times. I started this just a little bit, that you have on the top, it's a degree of 1, and on the bottom, it's a degree of 2. So if we look back at our little cheat sheet here, the top, the degree of the top is less than the degree of the bottom. So we are using this first situation. So what that tells you is that you have a horizontal asymptote of 0. So the horizontal asymptote is going to be y equals 0. Okay, again, horizontal asymptotes you are getting by comparing the degrees. The vertical asymptotes, you are then looking at the zeros of the bottom. So what you would do is on the bottom, you would go ahead and factor this to become x plus 3 and x minus 1. And so that's going to give you your two vertical asymptotes of x equals negative 3 and x equals positive 1, because those would be the zeros of the bottom. Okay, so moving on, we also have to find the asymptotes. If we look back at our little cheat sheet, or excuse me, your intercepts, we just found the asymptotes. So your x-intercepts are the zeros of the numerator. So where you are looking for that is up here. So x plus 2 equals 0, therefore x equals negative 2. So the ordered pair of that would be negative 2, 0. Okay, so we've got the two horizontal or there's two asymptotes, the one intercept, the other intercept for the y. All we would have to do is plug in 0, and when you plug in 0 up here at the top, you erase this, you're going to get a 0 here, you're going to get a 0 here, a 0 here, and so you're going to be left with 0, comma, negative 2/3 for your y-intercept. Okay? All right, so let's take a look at one more. All right, if you take a look at one more, you've got, oops, wrong one. First place you're going to look at is your degrees. So the degree of the top is 2, the degree of the bottom is 1. And so what that tells you, if you go back to your cheat sheet, the degree of the top is greater than the degree of the bottom. So this is our third option here. So when we look at this, notice that we have a funky asymptote going on that we have to do some division. So if we look at this, I'm going to go ahead and erase this, create a little space for me. I have x plus 3 on the outside, and I've got x squared minus 3x minus 7 on the inside. And so when I go ahead and do my long division, I would have x here, multiply around, so I get x squared plus 3x. When I subtract, I'm going to have negative 6x, bring my 7 down, so minus 6, and then I would have negative 6x minus 18, and I would have a remainder of 11. Now, here's the thing. This is the part that matters. So again, if you look back at the other side, or on the other slide, it is going to be the quotient without your remainder. So that's the x minus 6 at the top. So your asymptote that we just found is going to be y equals x minus 6. Now my other asymptote is coming from the denominator. So my vertical asymptote is when I set x plus 3 equal to 0 and solve. So in this case, it's going to be x equals negative 3. Okay, so those are my two asymptotes. And then I go on to figure out my x-intercepts. So my x-intercepts, I'm going to be setting the top equal to 0 and solving. Now, unfortunately, this is not one that you could factor. So what you would need to do in this case is you would need to go ahead and do your quadratic formula. And so when you do your quadratic formula, you've got the x equals the opposite of b, plus or minus b squared minus 4a negative 7 all over 2. which then will simplify if you do the decimals to be approximately 4.54 and negative 1.54. Okay, so your two x-intercepts then will be, let me do this in the same color here, it will be 4.54, comma 0, and negative 1.54, comma 0. The only other one that you need to find is your y-intercept. So again, you're plugging in 0 for x, which that will wipe out, that will wipe out, that will wipe out. So you're left with negative 7/3 for your y-intercept. Okay. So again, we are going to break this up into 2 days. As far as the learning component, if you guys have questions, please ask. But the number one thing that I would encourage you to do is just break it down step by step. Always have this part handy and ready to refer back to if needed. All right. Always ask questions if you guys need it. Otherwise, have a great one.